Okay, so let's begin 1.6. All right, this is number 2. We're going to do the evens instead. Simplify the following. Absolute value of negative 25, a squared. So with the absolute value, you can isolate it to the numeric portion and the variable portion. Absolute value of any negative number is positive. So you get a squared here. So it's just 25 a squared for that one. While I'm here, let's talk about 4. Find the distance between these 2 points. So as we know, absolute value is a way to find distance. If you were to write the absolute of a minus b, that's just finding the distance between point A and B. So let a equal negative 5.6 and let b equals 3.7. So if I add those two negatives, I get negative 9.3. And then, of course, anything in absolute value is positive. So the answer to 4 is 9.3. Okay, that's how I came up with that answer. Question 6. Solve this equation. You'll notice there's 2 answers to it. So in order to solve an absolute value equation, we're going to use the following principle. Any absolute value equation can be made into a positive equation and a negative equation. So here's the positive equation. There's the negative equation. I add 2 to both sides to get x equals 13, or I add 2 to both sides here and I get x equals negative 9. So both of these work. While I'm here, let me show you 8 and 10. Strategy here is to get the absolute value by itself. So I subtracted 6 on both sides, and the absolute value of x is equal to 19. But remember, any absolute value equation can be broken into a positive equation and a negative equation. So that's why we have 2 answers for that one. Number 10 looks like this. Even though you have a division going on, you can still break up into 2 equations, positive and negative. So here I multiplied 9 on both sides to get 63. Then I added 9 to get 72. Dividing by 2, I got 36. That's one answer. Here, the same thing, times by 9, I get negative 63. Add 9 on both sides, I get negative 54. Divide by 2, I get negative 27 out of that. Now let's go to number 12 because we just did 10. Okay, can an absolute value equation equal something negative? The answer for that is no. We know that an absolute value represents distance. Distance must always be positive, so the answer here is the empty set. All right, let's go to number 14. Okay, this one's interesting. I have 2 absolute value equations here. And let's look at that. So what you have to do is you still make a positive equation, and then you make a negative equation. Okay, so I solve this by subtracting 3a on both sides to get 5 equals a minus 7. Then I add 7 and I get 12 equals a. Okay, here I distribute the negative to get negative 4a. And then this is plus 7. So then I add 4 to both sides and I get 7a equals 2. Dividing by 7, I get a is 2 sevenths. So those were the 2 answers for that, 12 and 2 sevenths. Okay, moving on to 16. again, it's the same type of problem, so I'm going to skip it because you use the same process. Let's go to question 18. Okay, so here, let me show you how I worked it out. Well, that's 1.5. We don't want that. Okay. So for 18, we need to remember that for any positive number p and any algebraic expression x, the solutions of absolute x greater than or equal to p are those numbers that satisfy these two equations. The expression less than or equal to negative the quantity and the expression greater than or equal to the quantity. So here's my original question. So I make one equation that's positive, keeping the sign, and then I just make one equation that is negative. But I reverse the direction of the inequality. So that's why the answer was the following. Okay. We're going to use that same principle for this question with the y's in it. Anytime you have an absolute value with a greater sign, you just keep the inequality looking the same, drop the absolute value. Then you flip the direction of the inequality and make it negative here. Solving both of these yields y is greater than 3/2. And then solving this one yields y is less than negative 1/2. Okay. 22. How would I solve something like this? So here's the rule. If you have anything with less than or equal to that looks like this, you can split it up into a compound inequality. So notice this piece of the inequality stayed the same right here, but then I tacked on less than or equal to the negative quantity of the right-hand side. So that's how you set it up. And then you just add 5 everywhere. You get negative 5 is less than or equal to 7x is less than or equal to 15. And divide 7 everywhere. So you get x has to be in between negative 5/7 and 15/7. Of course, we'll include those values because it is less than equal to. So we'll include those. Let's show you what the answer looks like for 22. Okay, there's 22. So your inequality notation. Lowest value goes on the left. Highest value goes on the right. Okay. Last one here for the evens. Okay, this is a less than. Think, what rule are we going to use for the less than? Okay, so for any less than with an absolute on the left, it's going to look like this. You keep this piece of the equation, you move it here, and you drop the absolute value symbols. Take this number, make it negative, and notice the directions of these inequalities is all the same. So then I times 4 everywhere. To get negative 24 is less than x minus 2 is less than 24. Then I added 2 everywhere, and I got negative 22 is less than x is less than 26. So this is what the answer would look like in my lab math. All right, good luck on these questions. Again, remember, always welcome to view the textbook or the view an example. So thank you again for watching.